I want to review finding sample sizes. We've done this in two different sections, section 7.2 and 7.4. And if you look at your formula sheet, there are two different formulas for sample size. One of them is formula B here. This is used when you're trying to figure out a mean. Maybe you want to you find an average age, or an average test score, an average weight, average height, and you want to know how many people you have to survey. You use this formula. If you're trying to find a proportion, maybe you want to know the percent of teenagers that smoke, or the percent of West Delaware students that are going to go to the University of Iowa, that type of thing. If you're trying to estimate some type of proportion, and you want to know how big a sample size to get that you need, you would use formula E. What's the difference between those formulas, B and E, and the ones that I have circled here? The circled ones are for what? What are the circled formulas going to give me as answers? Well, you're estimating a parameter, but what are you going to get just one answer?
No, interval.
You're going to get an interval. You're going to get a confidence interval. So you have to really look carefully. If the question asks for a confidence interval for means, and n is greater than 30, or you know the standard deviation, then you're going to use this formula. If you want the confidence interval of a mean, and n is less than 30, and you don't know the standard deviation of the population, then you're going to use this formula. If you want the confidence interval for a proportion, then you use this confidence interval formula. And then today's lesson, lesson 7.5, which I haven't taught you yet, if you want to know the confidence interval for a variance or a standard deviation, you use one of these two formulas. So you got to read carefully. If it asks for a confidence interval, pick a confidence interval formula. If it asks for how big the sample should be, then you're going to pick either formula B or formula E. Okay? So we look at this example up here, which I made up. How large of a sample is needed? So right there you should know by reading the first few words, how large of a sample is needed. So you're trying to find n. Estimate the true proportion of high school students who drink alcohol at least once a week. Which formula do you think I need? So B or E? You're trying to estimate the true proportion. E, yep. So we're trying to find sample size, but we're not trying to estimate a mean, we're trying to estimate a proportion. So we're going to use this formula right here. So you just have to read carefully. If you don't pick the right formula, you're not going to get the right answer. So you have to start by picking the right formula. So n is sample size, and it says we take p hat times q hat. P hat is sample proportion, q hat is 1 minus p hat, times your z-score, divided by your maximum error of the estimate, squared. Now, so p hat would be your sample proportion. So I could go out and survey 50 students and ask how many of them drink alcohol at least once a week, come up with a p hat. But what if I don't know a p hat? What if I have no idea? I'm just like clueless. I have no idea what proportion of high school students drink alcohol at least once a week. Then what number should I use for p hat? 0.5. Yep, you're just going to figure half then. If you have no idea, use 0.5. So n is going to equal 0.5. Q hat is 1 minus 0.5, so that would also be 0.5. How would I know my z-score? I'd need to know a confidence level, wouldn't I? Which I don't have. I should have given you a confidence level. So let's say that we want to be 95% confident. That has to be given. I don't have it up here. Anyone remember what the z-score for 95% confidence is? Yeah, the empirical rule might help you remember that. Remember that 95% of the data is supposed to be within 2 standard deviations of the mean. So to be more exact, instead of 2, it's within 1.96 standard deviations of the mean. The other thing that you're going to need that I don't have up here is how accurate do you want to be? You want to be accurate within 2% or 1%. Let's say we want to be accurate within 5%. We're trying to estimate what percentage of the students use alcohol, and I want to be accurate within 5%. What would I put here for E then? 0.05. Yep. 5% is 0.05. Let's go ahead and type that in, see what you get. Turn this off for a minute. 0.5 times 0.5, and then times 1.96 over 0.05 squared.
384.16.
384.16. Now, if we round that down to 384, then we're not going to quite be 95% confident. We'd be a little bit less than 95% confident. If we want to be at least 95% confident, we have to round that up to 385 people. I would have to ask or survey 385 people to be 95% confident and to be accurate within 5%. Okay? Now it's possible and probable actually, I could probably go to the internet and Google high school alcohol use and probably come up with a number for p hat here. I could probably find a study somewhere where they asked high schoolers, or we could go out and do a study at lunch here at West Delaware and get a better number here. Okay? But if you have no idea, use 0.5. If they give you a sample proportion, then that's the number you use right here. Any questions about that? Okay, I'll just cut it off there.